Greetings and welcome. We're talking about measures of central tendency. Where does the center of a list of data exist, right? And we had a couple different ways of talking about that, and they were all types of averages. And this homework is from page 904, and we're taking a look at problem 16 for starters. It says crates of books are being stored for later use. The weights of the crates in pounds are 142, 160, 151, 139, 145, 117, 172, 155, and 124. What is the mean of their weights? So for part A, how would we find the mean of their weights? Well, I would add them all up and divide by how many there are, correct? Now, I'm going to actually partially use some Excel stuff here for us. So let's see, 142, 160, 151, 139, 145, 117, 172, 155, and 124. So the first thing you probably should have done is make a list, and since I see that the later problem is going to have us do a median, it might be good to sort that list. Right, so that would be worth finding. So here's our list sorted, I guess. So if I want to find the mean, I would add them all up and divide by how many there are. Let's see, so what does that add up to? Well, can I hit auto sum here? Is it that smart? Bam, look how cool that is, 1305. So 1305 is what that adds to. And then the question is, how many elements are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So the mean, which we refer to as x bar, is going to be 1/9 times the sum, right? Or 1305 divided by 9. And let's see, 1305 divided by 9 is 145, right? So that's the mean average, right? The arithmetic mean weight of each of those crates. Now, I can actually calculate, let's see, mean would equal, in Excel, do you guys remember the formula for mean? What does Excel call it? Yeah, they actually just use the word average. So bam, you see mean is 145. Not directly. Not directly. So let's see, for B, it says find the median of their weights. And median is another type of central tendency, all right? It's a middleness of the list. So let's see, we had how many numbers? 9. So because it's odd, there actually should be a middle number. So let's see if I cross off the top, the bottom, top, bottom, top, bottom, top, bottom. I end up getting a middle number, in fact, and the median happens to be 145. And is that not what the book said? Oh, good, it did. Woo. Right? And what I want to point out about medians is that if it was not an odd numbered list, then you'd have two numbers in the middle and you just find the mean of your two middle numbers, right? Or the midpoint of your two middle numbers. Now let's see, part C asks kind of an interesting question. It says, if 5 pounds is added to each crate, how much will the mean and median be affected? Well, think about this first of all. If I add 5 to all of these, all right, plus 5, plus 5, plus 5, plus 5, plus 5, and then divide by 9, what's the average of 9 5s? Right? It's going to end up just being, right, 5, right? If I add 9 5s together and divide by 9, it's just going to be 5. So adding 5 to all of these, since I'm affecting them all by the same amount, it's going to increase the average by 5. And actually, let's verify that. Let's write a formula where I say that is equal to that plus 5, right? So add 5 to the number on the left, And let's see if I double click, notice that, bam, it just auto fills to the bottom of that list. And let's see, let's actually, I'll just do this, bam. So this one's not part of the list, that's just the mean. And I wonder if I drag this over, is it smart enough? What? It is! Isn't that great? So yeah, the average of the list, since I added 5 to every element, it's just going to be 5 more than before, right? Since I increased them all by the same value. And then for the median, if this is my new list, well, the middle number, all of the numbers in order are still the same, and the middle number is also the same number, and all of them have, you know, they're all just 5 more, so the median is also 5 more. So each increases by 5. Right? And that's not necessarily intuitive, I don't think. But both of these end up being somewhat affected by, each element is affected the same amount, and it ends up working out that way. But not all kind of formulas end up being working that way, I guess. For instance, if I have like the area of a square and I say, okay, I increase the side length of a square by 5, its area will not increase by 5. Right? Its area is, you know, going to be affected by 5 squared, basically, and it's going to be thrown off by more than that. So here, let's look at the next question. Here's 17. It's a stem and leaf. It says, find the mean, median, and mode of the data represented in each stem and leaf plot. So, I just want to point out that this doesn't mean anything without this little legend or key telling us what it means, right? Because this could have represented 3005 if I didn't interpret that right, if I didn't have the key. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 numbers, an even number of them. So let's see, so n equals 12. So I'm going to have to add them all up and divide by how many there are. Let's see if we do the old Excel trick again. Let's see, where's my old clear contents? Bam, bam, there we go. So 3,5 means 35, then 3,8 means 38, and I've got 2 of those, 39. Then I've got 44, 45, 45, 45, 48, and 57, 57, 58. No way. Oh, and that one's still bold. That's fine. So here's my list. So if I want to find the average, the first thing I'm going to do is find the sum of that list, right? Bam. So there's my sum is 550. So the mean, x bar, is going to equal 1/12 times 550, right? Or 550 divided by 12, however you want to think about it. And that should equal 45.83 repeating, right? So that's the mean. Now the median, fortunately, stem and leaf plots are given to us in order. All right, they are in sequence. So let's try, and I know I'm going to have 2 numbers in the middle, so let's see what happens. So 1 from the top, 1 from the bottom. Top, bottom, top, bottom, top, bottom, right? Top and bottom. So now I've got 2 numbers left, so the median is actually going to end up being the midpoint between those, so 5 plus 5 divided by 2. And I think we just talked about the average of a list of 5s, coincidentally. So that's 10 over 2, so the median is going to just be 5 in this case. But not because I found one number in the middle that was 5, it's because I found 2 numbers in the middle that were 5, and their average became 5, or the midpoint. And then the mode, there's what? Did I? Oh, classic, shameful me. That's right, those aren't 5s, those are 45s, good call. So yeah, so that's 45 plus 45 is 90, and that, bam, that's 45, good call, thank you, good save. You got my back, appreciate it. Yeah, and there's, bam, right there. So the mode is the most frequently occurring number. Let's look at the contestants for the mode. I've got 38 and 38. I've got 2 of those. I've got 45, 45, 45. So I had 3 of those, and I had 57, 57. So the one that occurred the most was the 45, right? So that's why 45 is the mode. It's the most frequently occurring number. Now, if I had 357s, let's say, then you would have said that it is bimodal and that your 2 modes were 45 and 57. What if I had also 338s? What would you say about the mode of the list? It's actually no mode. So beyond a tie, a 2-way tie, it is no mode for our list. So yeah, trimodal sounds cool, and I just want to point out, so like for instance on this list there's no repetitions, but I didn't call this non-modal, well, I was thinking like non-nonagon, but non-modal and no mode sound kind of similar. But right, this isn't like a 9-way tie for mode, this is just no mode. There's no most frequently occurring number. All right, so that's worth pointing out. Bimodal exists, trimodal and beyond do not. Let's see, so there's that. Did I cover everything on that question? Yeah, that's all they wanted, mean, median, mode, bam. And now here's question 21. Let's follow along here. It says, the store manager of a discount department store is studying the weekly wages of part-time employees. The table profiles the employees. Find the sum of the wages in each class. Okay, so I know that I have 11 employees that earn somewhere between $130 and $140. So how would you find the sum of each of those wages? Because I don't actually know what they each earn. I could estimate it.
You do the sum of like 140 and 130
Well, no, that would be 270 times 11, so that would be way more. What do you think, Amber? Yeah, so basically with a frequency distribution, since I don't know the actual values, we just end up basing it off of the midpoint. And we're just like, we'll just assume that everyone in there earns 135. Chances are some of them earn more and some earn less. But on average, let's hope that they, all earn roughly that. It'd be a real shame if they all earned $139 and then this store manager is going to under budget. But that's the idea. So what I'm going to do before I go any further is set up a, let's see, here we go, little Google Doc frequency distribution thing here. So we kind of had this set up where we were able to calculate those things. And for this store manager's frequency distribution, his starting value is 130, right? And what is his class interval? 10, right? The range of any given class is 10, so he's counting by tens. Did this not work? Oh, what did I do? What did I do? Oh, they're referencing the wrong location. Yikes. So that should be B2. I can fix it though, fortunately. Here we are. Bam. And wha-bam. There we are. Good. So, yeah, that makes sense. Yeah, and he goes all the way down to 200, so I don't need those extra rows. And so the class mark, like Amber said, between 130 and 140 is 135. So let's find the frequency. Let's fill these out. 11, 24, 30. 30. And then 10, 13, 8. Right? And 4. Bam. Right? So, so when they ask for part A, find the sum of the wages in each class, what number on my list would help me answer that? Well, the class mark would be the average wage for each class, but how do I know what I'm paying everyone, all of those 11 employees? What's the manager's total spent money on those employees? Yeah, the frequency times the class mark. So the manager is spending $1,485, to cover the cost of those 11 employees, basically. So that's what part A would have been referring to, is the F times X stuff is what they would have been asking about. So A would have been this list, F times X. Let's see, and then it says, what is the sum of all the wages in the frequency distribution? So what would you do to find that?
Wouldn't you also do F times X and then get the sum of all of the F times X's?
Right, yeah, so if we just add all of these up, that would give me the sum of all of those wages, right? And this is technically still an approximation. So 1,5,800 is an approximation of that, okay? And then it says, C, find the number of employees in the frequency distribution. Let's see, how many employees is he actually paying here? Well, I know how many are in each class, so if I just find the sum of the frequencies, right? So there's the 100, right, that it's referring to. Right, there we are. So there's the 100. Actually, I'll even zoom that in a little bit. Right, so there are 100 total employees. And then they say, what is the mean weekly wage in the frequency distribution? So based off of this information, not even considering the formula, how would you have calculated that? On average, what is the manager paying out per employee?
Wouldn't you do F times X?
Well, are you saying this divided by how many workers?
How many classes? Yeah.
Right, the total salary being paid out to all employees divided by our total number of employees. Now, question, I said earlier that this is an estimate, but is this an estimate?
No.
No, it isn't, because we know exactly how many employees we have. We just didn't know how much they were each individually getting paid in those classes. So in order to find out the X bar, which is an approximation, X bar, I guess technically I could even use squiggly equal sign here, would just be 15,800 divided by the 100 employees, and I'd get an average wage of $158 a week. Right? And then let's see, here we go. I just hit a number. So pointing that out in this list, this is where that X bar comes from. Right? It's finding the average of these two things. Or not, sorry. It's dividing those two things, and it's approximating the average of all of these employees' salaries based off of the class marks. So it's an approximation because we didn't really know all of those 11 employees earned $135 a week. We just knew that that would be the midpoint of what they all earned. So that's why it's an approximation. And so you may recall that the formula, I just want to point out, A, B, C, and D were all necessary in calculating the formula for X bar. And X bar, the formula was what? 1 over N times the sum of I equals 1 to, there was what? K classes. And we multiplied what? Actually, oh, wait. I just did this wrong. Whoop. That 1 over N is not part of it. That's part of the other one. It was sigma of I equals 1 to K of the frequency of each class multiplied by the class mark of each class, right? So that's what this one. The sigma is telling me to find the sum of that, which is this. And I divided by this number, and how do I represent that? Well, that was a sum of another list, so sum means sigma, where I is equal to 1 to k of, and what are these values each called? Those are, right, F1, F2, F3, so those are the sum of the Fi's, right? So this is the formula we used for approximating the mean in a frequency distribution, right? Now they end up asking some interesting questions. It says, find the median class of the frequency distribution. That's actually a really interesting question. The median class. Let's see, let's do part E down here. So based off of that information, all right, how would I find the median class? Which employee lands exactly in the middle of this list? Now I know I've got 100 employees, so it's going to be somewhere between employee, what, 50 and 51? So I just got to figure out where do employees 50 and 51 land as far as my classes go. So let's see, here's 11 employees. That would be 35 employees, right? So I haven't crossed the threshold yet. Once I'm in here, that's 65 employees. So that means somewhere within this group of employees, we actually had the median employee salary, right? So somewhere between 150 and 160 is where that ended up happening. So that's a really interesting question because, right, we don't actually know what the median wage is, but I can still figure out what the median class is just based off of knowing, that the 50th and 51st employee was somewhere in there, right, as far as that being ordered from greatest to least. Let's see, F says estimate the median weekly wage in the frequency distribution. So okay, this is going to be an estimation because, like I said, I know that the median class is this, but I don't know how much each of those employees are making. I know 30 of them earn, some amount of money within that range, but we don't know the exact value. So the best estimation I can give is the class mark. And that's why the answer to F is $155. Right, so we didn't talk about medians in a frequency distribution, but it's an interesting sort of concept. And then G says, explain why both mean and median are good measures of central tendency in this situation. And they said both values represent central values of the data, right? And that's the idea of the measure of central tendency. The median represented kind of the middle-ish number in the list, and the mean, which was, they're both approximations in this case. However, the mean is also kind of a middle-ish number. Let's see. So notice our mean was 158 and our median was 155. So they're close-ish to each other with respect to the scale of, quantity that we were talking about. So they both work pretty good, right? They're both pretty center-ish numbers. So anyways, friends, thanks for watching. Have a great day. There we go. Bye-bye.